My task is to give some technology definitions that are important to computer literacy and computer education in general, or as I like to call it, technology education. I feel like that's a more general term that covers most of what we're talking about here. So why should we listen to this guy? It's important to establish credentials. So I teach at Sunset High School. I cover a ton of different classes: robotics, game design, web design, 3D modeling, programming for Java and C++. I've covered IB Computer Science, and I teach 12 credits worth of computer science classes through Portland State University's Project Challenge program. I also teach for Saturday Academy. I've done game design camps, artificial intelligence, Java through game design, robotics, so on. I've also done some research at Lewis and Clark University with Professor Peter Drake on the game of Go, attempting to make it beat humans. We're not there yet, but we're getting closer. In 2012 and through 2013, I was also the president of the Computer Science Teachers Association, the CSTA. So first, one of my minors was art history, and so I like to focus on some mythology that a number of people have. First of all, students just know how to use technology. This is a pretty common myth that many adults have, that the younger generation just automatically comes with this pre-programmed knowledge of how technology actually works. And that's all I need to know, so I'm not going to do any deeper knowledge. They don't understand how the machine works, how the underlying structure works, how the file systems works, any of that. An example in my district, Beaverton Middle School teachers spend the vast majority of their time helping students to log in. So just that very basic idea is a real problem. So another myth I'd like to cover is that if you just put a piece of hardware in front of a student, an iPad for example, that's the same thing as technology education. The device, while being very shiny, does not actually create this environment of innovation. A well-educated teacher using the tools effectively is what actually makes the technology education work. In fact, there are times when a device in front of a student actually might be more distracting than it is educational. There are a number of times when students have trouble avoiding the internet while attempting to do work. Adults have that problem too, for that matter. I'm not going to hold it to just students. And there's a fact that computational thinking, this idea of like how to solve problems, this can actually be taught without using computers. We could actually teach computer science with no computers, as strange as that idea sounds. The way you think about things and the way you break down problems and solve them is actually the core thing that we're looking for. Another myth: you can just infuse technology education in the existing subjects. So you can use technology to better run other classes. So if I use iPads, for example, or some other piece of technology in order to facilitate discussions in social studies, that is a great use of technology. But that is not the same thing as teaching them how the actual devices work or how to break down problems and solve them. So math and science are pretty common subjects where people say, well, just put it into there. I mean, they're related, right? And yes, they are related. For example, technology programming classes do use a certain amount of math, though it tends to be things like adding, subtracting, and that's some basic logic. Engineering, the design cycle is very similar to the scientific method, just a very short version of it. But they're not quite the same thing. It's a different methodology that goes into them. And to be perfectly honest, math and science are already struggling to meet the standards that are already placed in front of them. So the idea of just loading more things in without pulling anything out of those subjects seems unfair and kind of crazy. So computer literacy, what is it? So this is the ability to use a computer effectively in general. Some basic technology skills would be things like, how do you search the internet and look for information? That's probably one of the most important skills that students need to have. If you have that skill, you can learn many, many others. Basic keyboarding is pretty useful if you want to be productive and quick in actually producing code or solving problems. Office software is used in a number of other subjects, though usually what happens is people assume that everyone knows it, and sometimes students don't. Particularly how to type up a paper, for example. And similarly with presentations. You just know how to use PowerPoint because you've made it to high school, right? Not necessarily. Some students have never been taught that. How do you save files and move files around? And how do you navigate through folders? This is actually something that a number of students do not know how to do. They save files to a desktop, and then they move to another computer, and they're like, where did my files go? I should just have them. As though like somehow through the ether, the computers know to just pass it along. Not quite the same thing. So computational thinking is something I mentioned earlier. What is that? So that's how you break large problems down into pieces and solve them. It's a systematic approach. So most computer scientists will kind of say, well, this is really the core thing that we're looking for. So regardless of which programming language you use, Java or C++ or Python or whatever else, they all are related in that what you're doing is you're actually taking a set of tools that you have and solving a problem. So this doesn't even necessarily need to be a computer problem. It could be other things. It's a more fundamental skill that's actually valuable to all students. So STEM education, this is kind of a big buzzword right now. So there's a lot of money that's going into STEM, science, technology, engineering, and mathematics. When you get into educational systems, what you'll find is that there's lots of positions being created for science and math, because science and math are already core classes, there's already requirements, so education and school districts are very excited about science and math. Now, to be perfectly honest though, what industry is talking about is actually technology and engineering, which school districts are largely ignoring. Let me give you an example of that. So through 2022, US Bureau of Labor Statistics says that in all STEM fields, science, technology, engineering, mathematics, 71% of them are going to be in computer occupations. 15% are going to be engineers. The remaining 14% is all the rest. Something I want to emphasize real quick is that this gray here is life sciences. So doctors. We have lots of programs that emphasize that very small 14%, and there's a lot of schools that don't even have computer programming classes or any other kind of technology classes. Let me talk about computer science, which is what I'm referring to as the T in STEM, the technology side. So create systems that solve abstract problems. So if you are dealing with any kind of computer system, it's probably something that you need to create that you may not be able to physically see, but you still need to solve it. So there are a number of classes that currently exist that would meet this requirement. So IAP and IB Computer Science is an obvious one. But what about other kinds of programming? So C++ programming, Python programming, whatever. Video game design very much needs this kind of abstract problem solving. If I want my ghost to be pointing the right way, I need to be able to solve that using the computer. Web design could be, although a quick warning, using like Google Sites or templates is not the same thing. Drag and drop templates doesn't actually have programming. You're not actually learning how the underlying structure works. So if web design has programming to it, such as JavaScript or cascading style sheets or something like that, where you're actually having to fiddle with the code underneath, then it counts. Graphic design could be, although really you would be needing to create some sort of step-by-step process to create the graphic design, so feeding the computer some sort of code that would create the graphics you want. So I want to talk real quick about engineering as well, which is the E in STEM. So this is where you're dealing with physical systems. So a physical machine, a physical system where you're solving problems. So you can kind of think of this as the maker movement, if any of you have heard of that. So current classes include things like robotics. You're creating physical robots to solve problems. Electronics. This seems somewhat abstract, but you're creating physical conditions. Automotive has a ton of technology in it. There's so many computers in cars nowadays. Metal and wood shop, actually. So the actual construction of physical things to solve problems, whether that be you need to create particular pieces that fit together to create a house, or you're creating tools for use in other activities. You could have physics classes that specialize in this, although a lot of physics also focuses on things that are somewhat abstract, so it would have to be the physical side of things that would count as an engineering. 3D modeling and printing actually has a certain amount of engineering in it as well, especially if you're creating actual physical components. So currently in the system, one of the groups that's trying to meet these needs is career technical education, which is a blanket term. There are many different job skills that are taught in CTE. So career technical really is about creating people that are going to have a pathway from high school directly into a career, possibly through advanced training. And this includes a ton of different subjects. So computer science is one of them, so is automotive, health careers, culinary, business, welding, anything that's like goes directly into some sort of trade. So computer science is a very small piece of this career technical ed. In Oregon, this is an add-on endorsement. So you have to be endorsed in some other subject in order to get a career technical education license. There is some funding that goes with it, Perkins money. That goes to the school district, not necessarily to the classroom, but to the school district. And they decide how to share out that Perkins money.